Ladies and gentlemen, welcome to the Babylonian Mathematics. Today, we have goods that worth of thousands and millions. Are you guys ready to bid your money? Let's not prolong it any longer and let's start the fun!
So our first action for today, it is the clay tablet of the Babylonian. This is the world's oldest and most accurate trigonometric table that existed during Babylonian era.
It was the clay tablet that my grandfathers talk about. It was the clay tablet of the Babylonian.
Mariel, I want you to find the treasure our ancestors trusted to us. I have information that someone discovered it in Elec, but I'm not sure. You have to find it and keep it away from wrong people. Those tablets helps our ancestors to build canals, buildings, wheels, houses, and so on.
I promise, Pops. Going back, this region was the center of the Sumerian civilization, which flourished prior to 3500 BC. This was a sophisticated civilization that built cities and provided for its people with irrigation system, a legal system, and administration, and even a postal service. Writing and counting were developed using a sexagesimal system, or base 60. Around 2300 BC, the Akkadians invaded the area, and for a title, the Akkadians' more backward culture mixed with the Sumerian more advanced culture. The Akkadians invented the abacus as a counting tool, and they developed somewhat clumsy attribute methods that included addition, subtraction, multiplication, and division. The Sumerians, on the other hand, revolted against Akkadians' rule and were back in power by 2100 BC. Why am I telling you this? It's simply because it relates to the origin of this clay tablet in front of you. The Sumerians created an abstract writing based on a cuneiform, a wedge-shaped symbols. Their symbols were written on wet clay tablets that were baked in hot sun, and thousands of these tablets have survived to the present day. Because curved lines could not be drawn with a stylus on a clay medium, cuneiform symbols were invented. Later, Babylonians used the same cuneiform writing style on clay tablets, and the mathematics that developed by the people of Mesopotamia from the days of Sumerian up to the fall of Babylon in 539 BC is called as Babylonian mathematics, also known as Assyro-Babylonian in mathematics.
The bidding starts at $100,000.
$250,000.
I promise, Pops, I will get it. $300,000.
$300,000. Going one, twice, sold. Thanks to Miss Mariel.
And the next items are the transcript of the Babylonian numerals and the sexagesimal system.
That's the transcript my grandparents had in their home. The Assyro-Chaldean Babylonian cuneiform numerals and numerals written in cuneiform using a wedge reed stylus to make a mark on soft clay tablet, which would be exposed in the sun to harden to create permanent record. But why did it appear here? This system first appeared around 2000 BC. Its structure reflects the decimal lexical numbers of the Semitic languages rather than the Sumerian lexical numbers. However, the use of a special Sumerian sign for 60 attests to a relation of Sumerian system. And here comes the Babylonian system. Is credited as being the first known numeral positional system in which the value of a particular digit depends both on a digit itself and its position within the number. This was an extremely important development because non-place value digit require unique symbols to represent the each power of base, which can make calculations more difficult. Babylonian system of mathematics was a sexagesimal numeral system. From this, we derive into a modern day usage of 60 minutes in a hour, 60 seconds in a minute, and 360 degrees in a circle. The Babylonians were able to make great advances in mathematics for several reasons. Firstly, the number 60 is superior highly composite number unlike Egyptians and Romans. The Babylonians had a true place value system where digits written in the left column represented larger numbers. The Babylonians divided the day into 24 hours, 60 minutes, each hour into 60 minutes, each minute into 60 seconds. This form of counting was survived for 4,000 years. So these transcripts here are very valuable item.
Let's start the bidding by $200,000.
$1,001.
$350,000.
$400,000.
$450,000.
Wow, so persistent. Never mind, I came here for the clay tablet. $400,000. Going once, twice, sold. Thank you so much for billing your money, Mr. JC. Everyone, this is so intense yet fun, right? Everyone? And for today's special event comes the special items. Thanks to the Babylonian everyone. The last but not the least, the 4 tablets of Babylonian mathematics. The Elec tablet YBC 7389, the Plimpton 322, the Susa tablet, and the last, the Tel Dibai tablet. Impossible! There are 4 tablets, but that's the Plimpton and the Elec tablet that I've been looking for. Pops, Granny, our tablets were here. Finally! My dear, Elec tablet YBC 7289 is a Babylonian clay tablet notable for containing an accurate sexagesimal approximation to the square root of 2, the length of the diagonal of a unit square. This number is given to the equivalent of 6 decimal digits, the greatest known computational accuracy in the ancient world. The tablet is believed to be the work of a student in southern Mesopotamia from sometime between 1800 and 1600 BC, while the other one is the Plimpton 322, is a Babylonian clay tablet, notable as containing an example of Babylonian mathematics. This tablet believed to have been written about 1800 BC has a table of 4 columns and 15 rows of numbers in the cuneiform script of the period. The math content of Plimpton 322 is a table of numbers with 4 columns and 15 rows in Babylonian sexagesimal notation. It is the most famous of old Babylonian tablets. It is the world's oldest trigonometric table, possibly used by Babylonian scholars to calculate how to construct step pyramids, palaces, and temples. There is an untold story behind why the tablets were missing. No, it's not really missing. Our ancestors hid it to protect from the soldiers back in 539 BCE. That time, the empire fell to the Persians under Cyrus the Great at the Battle of the Opis. Our ancestors were afraid of what will happen, so they hid it somewhere in Babylon. And since then, ancestors after ancestors never gave up to find it, because that's our treasure. Yes, Granny. Those 2 tablets over there were our treasure. And this tablet was called the Susa tablet. It's a tablet dates to the old Babylonian period. The tablet contains a problem about the isosceles triangle and the circle through the 3 verticals. The last one is the Tel Dibayi tablet. It is an old Babylonian clay tablet in the collection of the National Museum of Iraq that contains the solution to a problem in plane geometry concerning a rectangle with given area and diagonal. And the last part of the text, the solution is proved correct by means of the Pythagorean theorem. The steps of the solution are believed to represent cut and part geometry operations involving a diagram from which it has been suggested ancient Mesopotamians might, at an earlier time, have derived the Pythagorean theorem. Everyone, let's start the bidding by $400,000.
500,000. Now back off.
Wow, Miss Keen. That's a lot of money. For someone like you. $2 million!
$3 million. $3 million. Going twice. Sold. Thank you, Miss Marielle. And that's the end of the auction. Enjoy the rest of the party, everyone. Granny, Pops, I did it! Our ancestors may now rest in peace.